We're going to look at several different heparin calculations. We're looking at this because heparin can be given as an injection or heparin can be given as an IV infusion. Let's take a look at several problems. In our first problem, heparin is to be given as a subcutaneous injection. And so we see here an order of heparin for 16,000 units subcutaneously stat, and we see a med label telling us how strong the heparin is. In order to figure out how much to administer, I'm going to use dimensional analysis. Keep in mind that this problem could also be done using the nursing formula or using a proportion. So the order is for 16,000 units. Be careful with all those zeros. And that is given as a one-time dose. The strength of the med is 20,000 units, and I put that on the bottom of my fraction so that the units cancel. And that 20,000 units is in 1 milliliter. So my label of units will cancel, and I'm ready to go to my calculator. On my calculator, I'll type in 16,000, and I'll divide it by 20,000. Come up with an answer of 0.8 milliliters. So on my work, this will equal 0.8 milliliters. Because this amount is under 1 ml, if needed, I could round it to the 100th place or 2 digits in the decimal. However, I did not need to round for this particular problem. Let's take a look at a second problem. This time heparin is to be given as an IV infusion. We see an IV bag. We'll notice that the strength of the med is given in 2 different places on the IV bag. We can use either concentration, the amount for the full bag, or the reduced fraction. They truly are equivalent. Again, I look at my order. This time my order is for 1,500 units per hour, and I should figure out a milliliter per hour rate. I'll start with the ordered amount, and I'm going to use dimensional analysis. Although again, it's possible to use a proportion or to use the nursing formula. In dimensional analysis, I'll start with the 1,500 units per 1 hour. And then I'll multiply by the strength of the med. I'll use the reduced fraction, although it truly does not matter. In the reduced fraction, there were 100 units per 1 milliliter. The units cancel, and I'm ready to go to my calculator. On my calculator, I type 1,500 and divide by 100 units per milliliter, and my answer is 15 milliliters per hour. Because this is an IV rate, I would typically round this to tenths if necessary. In this case, I did not have to round. Let's look at one more problem. This problem asks us how much heparin will the patient receive. We're told that heparin with 40,000 units and 500 milliliters of 5% dextrose water is to infuse at 30 milliliters per hour. We're asked to calculate the hourly heparin dosage. So I'm going to take the information that I'm given, this rate, and change it so that it is units per hour, which is how heparin would be measured. I'm going to do this with dimensional analysis. This particular type of problem is harder to fit into the nursing formula. You could set it up as a proportion, but truly dimensional analysis is probably your easiest option. In the dimensional analysis approach, I want the milliliters to cancel, so I'll put the 500 milliliters from the IV bag on the bottom of my fraction. The 500 milliliters goes with 40,000 units. And in this setup, the dosage strength has allowed me to change the milliliters into units. Go to my calculator, and I take 30 times 40,000, be careful with all those zeros, and then I divide that by 500. I get my answer of 2,400, and that would be units per hour. So I have converted a milliliter per hour rate into a unit per hour rate so that I know the amount of heparin the patient will receive.